Advanced Level Chemistry, Unit 1, Atomic Structure. In this video, it is going to be explained the subject matters related to structure of matter. You will be able to use this video series to improve your A-level chemistry knowledge thoroughly. On the other hand, you all can use the subject matters presented here as a note successfully to face the A-level examination properly. We will see the details on the Unit 1, Part 1. First of all, we should get an idea about the matter. What is called matter? Matter is everything that has a mass and occupies space. Actually, matter is the physical material of the universe. The properties of materials or substances in our environment are different from one another. You know that some substances exist in solid state, some of them are liquids, while some others are gases. So their properties are different. Although these materials are differ, everything is made from only about 100 elements, and therefore from only about 100 chemically different kinds of atoms. Now we will move to the atomic theory of matter. The atomic theory of matter. Philosophers from the earliest times suggested various ideas about the nature of the fundamental components from which the world is made. You know that people in the past started to find out the nature of the fundamental particles that the matter is made. Among them, Empedocles. Empedocles believed that the four elements, earth, fire, air, and water, made up all things. Then Democritus. He explained that the material world is made up of tiny, invisible, indivisible particles called atomos, meaning indivisible. Right. Democritus explained that the substances around us are made up of tiny, invisible, and indivisible particles. He named these indivisible particles as atomos. Atomos means indivisible. Okay, next, Plato and Aristotle. They said that there can be no ultimately indivisible particles. No ultimately indivisible particles. And the atomic view of matter faded for many centuries. Right. Plato and Aristotle believed that matter does not contain indivisible particles or atoms. John Dalton. John Dalton suggested a precise definition for the indivisible building blocks of matter, that is called atoms. Right. John Dalton is the first scientist that suggested a precise definition for atoms or indivisible particles. Actually, Dalton presented an atomic theory that is called Dalton's atomic theory. Dalton's atomic theory was based on four postulates. First one, elements are made out of extremely small indivisible particles called atoms. Okay, this says that every element is made of atoms. Second one, all atoms of a given element are identical in mass and size, but the atoms of one element are different from the atoms of all other elements. For example, all carbon atoms are identical in mass and size, but carbon atoms are different from silicon atoms, like that. Third postulate, atoms are neither created nor destroyed in chemical reactions. Fourth one, this says that compounds are formed by union of two or more atoms of different elements in a simple numerical ratio. Right, compounds are formed by combining two or more different atoms in a simple whole number ratio. For example, water, H2O. You know that a water molecule is made out of two hydrogen atoms and one oxygen atom. The ratio between hydrogen and oxygen atoms is 2 to 1. It's a simple whole number ratio. Likewise, the other compounds are also formed in this way. Right. Those are the postulates of Dalton's atomic theory. After that, Dalton presented an atomic model. According to Dalton, an atom is spherical in shape, like a golf ball. So Dalton's atomic model is called the golf ball model. Right, atom is like a golf ball. Now you see the golf ball model, Dalton's golf ball model. Right, this is the Dalton's atomic model. In 1874, Johnston G. Stoney pointed out that, like matter, electricity is composed of small discrete units of electricity. He gave the name electron for these fundamental units carrying electricity. Right, Stoney said that electricity is composed of small discrete units. These fundamental units carrying electricity were named as electrons by Stoney. But Stoney could not prove the existence of electron. However, the electron was discovered later by J.J. Thomson during the experiments on conduction of electricity through gases at extremely low pressures. Okay, they carried out some experiments to see whether gases can conduct electricity at low pressures. These experiments done are called discharge tube experiments. Discovery of electron. Now we will look into the experiments conducted to discover the electron. Actually, these experiments were carried out by William Crookes and others. Cathode ray tube experiment. These cathode ray tube experiments led to the discovery of electron. Let's see the experimental setup that William Crookes used during the cathode ray tube experiments. This is a discharge tube. Actually, it's a closed glass tube. It is also called cathode ray tube. There is a gas inside the tube. It can be any gas, helium, oxygen, like that. Two metallic electrodes are available on both sides. This is the cathode or negative terminal. This is the anode. There is a vacuum pump connected to the discharge tube like this. It is possible to maintain any desired pressure inside this discharge tube by pumping the gas out through this evacuated pump. Right, this is the evacuated pump. Two electrodes are connected to a high voltage supply. This is the voltage supply. We can give 5 to 10 kilovolts from this power supply. Right, it is connected to the two electrodes like this. Okay, this is the experimental setup that William Crookes used. When the pressure inside the discharge tube becomes very low and the voltage difference between these two electrodes is high, a stream of invisible rays emitted from the cathode like this. These rays are called cathode rays. Right, now we will see this experiment in details. The experiments of William Crookes and the others consist of a cylindrical hard glass tube closed at both ends called discharge tube or Crookes tube, as I showed you earlier. It is fitted with two metallic electrodes, cathode and anode, and the tube is connected to a side tube through which it can be evacuated to any desired pressure with the help of a vacuum pump. Okay, the discharge tube filled with the gas under study, and the two electrodes are connected to a source of high voltage. It is 5 to 10 kilovolts. Then they showed that when two electrodes are connected to a high voltage source, the cathode or negatively charged plate produced a stream of invisible radiation under extremely low pressure inside the tube. Although these rays could not be seen, their presence was detected because they cause gases at low pressure to glow, and which made other substances to give off light. This radiation emitted from the cathode was named as cathode rays. Properties of cathode rays. First one, the cathode rays start from cathode and move towards the anode. Right. Cathode rays start from cathode and move towards the anode. Second one, cathode rays travel in straight lines in the absence of an electric field or magnetic field. This simple experiment helps in understanding this property. You can place a metallic object like this inside the discharge tube during the cathode ray experiment. This is the metallic object. When cathode rays travel through this metallic object, what happens is this object casts a shadow on the wall opposite to the cathode. Right, the shadow is on this wall. Cathode is here. The shadow is on this wall. Right. This indicates that cathode rays travel in straight lines. Third one, cathode rays possess kinetic energy. You can use this simple experiment to prove that property also. What you have to do is place a light paddle wheel like this. This is a paddle wheel. When cathode rays hit this paddle wheel, it starts to rotate. This effect is due to the kinetic energy of cathode rays. Okay. When cathode rays hit this paddle wheel, it rotates. This indicates that cathode rays possess kinetic energy. Then cathode rays have the ability to ionize gases. Cathode rays can ionize gases. When cathode rays hit gas molecules or atoms, electrons are emitted from these gaseous atoms and becomes positive ions. For example, when cathode rays hit hydrogen atoms, electrons are emitted and these hydrogen atoms become H plus ions. That is ionization. So cathode rays can ionize gases. We'll move on to the next property. Cathode rays are negatively charged. They are negatively charged. You can show that cathode rays are negatively charged too. It is possible to apply a electric field like this. This is the negative plate of the electric field. This is the positive plate. Right, you can apply an electric field like this to the cathode rays in the discharge tube. The cathode rays produced are deflected towards the positive plate like this. These are cathode rays, right? This indicates that cathode rays are negatively charged because they are deflected towards the positive plate of the electric field, right? Or you can apply a magnetic field also to the cathode rays like this. This is the magnetic field. Actually, this is the direction of the magnetic field from north pole to south pole. When cathode rays pass through this magnetic field, cathode rays are deflected in a right angle to this magnetic field like this. Cathode rays do not deflect towards the south pole or towards the north pole. Cathode rays only deflected towards this direction with a right angle to this magnetic field, right? This also indicates that cathode rays are negatively charged. Next one, the characteristics of cathode rays do not depend upon the nature of electrons and the nature of gas present inside the cathode ray tube. The properties of cathode rays are the same, although you use different gases or different electrodes in discharge tube. For example, the ratio of charge to mass or E upon M is the same for all the cathode rays, irrespective of the gas used in the tube. You can use any gas inside the tube, but charge to mass ratio of cathode rays produced is the same for all gases. Then J.J. Thomson was able to calculate the value of charge to mass ratio. Thomson calculated the charge to mass ratio of cathode rays. The value of E upon M is this value 1.758820 into 10 to the power 11 coulombs per kilogram. This is the value of E upon M ratio. Then Robert Millikan found the charge of the electron. The charge of the electron is 1.6021 into 10 to the power minus 19 coulombs. That is the charge of the electron. Then you can easily calculate the mass of the electron. Charge to mass ratio is this value. Charge of the electron E equals 1.6021 into 10 to the power minus 19 coulombs. Now you can make M the subject, E over E upon M, and you can now substitute the values for E and E upon M like this. And after solving this expression, you will get 9.1094 into 10 to the power minus 31 kilograms. This is the mass of the electron. Okay. All these observations concluded that cathode rays consist of negatively charged particles or electrons. These negatively charged particles constituting the cathode rays were named as electrons by J.J. Thomson. Right, cathode rays consist of negatively charged electrons. Electrons were named by J.J. Thomson. Right. The discharge tube experiment showed that the electrons constituting the cathode rays are the same, although the material of the cathode is changed and the gas used in the discharge tube is changed. Although you use different gases or different materials for cathode in the discharge tube, the electrons constituting the cathode rays are the same. Right. All these electrons possesses the same mass and the same charge, and therefore they have the same charge to mass ratio. Okay. All these electrons have the same charge to mass ratio. Right, then they concluded that electrons are universal constituents of all matters, and the electron is considered to be a fundamental particle of all atoms.